Plate fin heat exchanger, definition, working, applications and concepts. What is plate fin heat exchanger? A plate fin heat exchanger is referred to as a type of heat exchanger which is specifically designed that is found using plates as well as fin chambers in order to transfer heat within the fluids. These are some of the commonly known and are thus categorized as a compact heat exchanger, which emphasize its relatively high heat transfer surface area to volume ratio respectively. Construction of plate fin heat exchanger. Plate fin units are referred to as the ones which are normally found to be arranged for the counterflow heat exchange. Cross-flow units are the ones which are commonly used for the vehicle radiators, and also cross-counterflow is used for the liquid subcoolers. This is the way by which the heat exchanger is found to be built up to an appropriate height, after which it is found to be brazed together, wherein the headers and the pipework are found to be welded over the inlet as well as the outlet parts of each stream in order to give a finished unit. Layers are found to be normally arranged accompanied with an alternating hot as well as cold streams. An alternative system can be referred to as a double banking, whereas a three-stream unit is found being made by using all the fin arrangements. Characteristics of plate fin surfaces. There is a method by which a stream is found occupying layers at one end of a block, which is found to take out at part length and get replaced by other stream at the other end of the considered block. This step can be repeated wherein the ethylene exchangers are found to be responsible up to 5 streams, which usually occupy the same layers for different lengths. There is a variation of the system which is responsible for allowing a part of the stream which needs to be taken out at part length. There is a use of all these features which permits a high degree of process intensification for a single block. There is a maximum number of streams found in one block, which is commonly known to be 10, out of which 3 have partway takeoffs or additions. Brazing and materials. Aluminium units are found useful material in the exchanger block. The material of braze if known to be silicon. There are plates which are found to be purchased within a thin film of brazed metal on both of its sides. The unit is usually found to be built and is thus placed in a vacuum furnace. Braze can take place under the presence of vacuum, and that too at a temperature difference of 580 C. The parts of the block after this are then firmly attached together. Plate heat exchangers. The fluids are usually observed crossing the channel which is meant for that, in either series or parallel method, by making the countercurrent or the current configurations. The serial configuration is being used whenever there is a small flow rate for each fluid where there is a high heat jump. The greatest problem which is found is the high pressure drop that can be an example of imperfect countercurrent. There is a great difference observed within the flow rates or within the maximum permissible pressure drop of the two fluids. Plate and frame heat exchangers. In FEI there is found a plate which is responsible for creating a frame where the plates are pressed along with the headers and the tie bars, along with which the seal is also guaranteed by the gaskets. In addition to their effect of sealing, the gaskets are also responsible for serving the direct flow of the fluids which are placed along with the grooves at the edges of the plates. The maximum temperatures which is considered for the purpose of sealing the heat exchangers is found within 80 C to 200 C, whereas the pressures can also reach up to 25 bar. Easy as well as quick dismantling for cleaning and control operations is possible. Brazed plate heat exchangers. The corrugation height B is found having an important effect with respect to the exchange coefficients, as a greater depth seems to be responsible, which can cause greater turbulence. Adaptation of variable operating conditions by the addition or subtraction of heat plates in order to modify the installed thermal flow. Any fluid which is found to leak due to the effect of non-perfect sealing of the gaskets may not contaminate the other fluid, as these are directed away. Whichever materials are poorly adapted to soldering like titanium are found to be used commonly. There is a gasket's limit in terms of maximum pressure as well as temperature values. Potentially there is a high cost due to the design of molds that presses all the production process. Thanks for watching.